All right, everyone, we are back and we are going to do question number 3, which involves hypothesis testing. So, I want to drill down further on grain size. Somewhat of a pun. Um, but, anyways, let's see what we got here. So, let's go ahead. Let's take a peek. So, I am told 3 products. So, I have P1. Actually, let's go ahead. So, X1. And then we're going to set that equal to 47. And then control enter. So X1 is 47. S1 is 0.1. Good. And then N1 is 27. Good. N2 is 57. X2 is 49. And then S2 is 1. And N3 goes to 8. N3 goes to 8. X3 goes to 45. And S3 goes to 5. There we go. Now we are asked, okay, are product 2 and 3 different at a 10% significance level? So here we're actually comparing products directly. So this is the point now where I am actually going to go into, Canvas. I'm going to find, not that course. I'm going to find our course. I'm going to look at, let's go ahead and look at our files. We're going to go in and get in our lecture, not our lecture notes there, but our lecture notes. If we're doing comparison, I'm going to take a peek at this one. So let's look at, and let's open this up. And let me move this over here just a little bit. I'm going to build in this function we already have available to us, but I'm going to steal these functions. So I'm going to grab this and this for sure. And I'm going to read it in here because we need this t-test comparison. So we got this, new comp. And now let's go ahead and let's start. So we're asking basically a hypothesis test of, are they the same or are they different? So it's a two-tailed test. So I know, for example, my alpha is going to be equal to 0.1, but it's a two-tailed test, so it's alpha over 2, so it's 0.05. So if they are different, so if I'm going to reject H naught, which is that they are basically the same, I need to have my p-value be less than this. So be careful, or, well, not necessarily my p-value in this particular problem because we're not going to be able to do that t-test comparison, but we'll get that. So let's actually go ahead and be systematic with this. Here we go. Let me erase. So let's do step 1, H naught. So x2 bar is equal to x3. 2, alternative, not 3, alpha equals 0.1, but it's alpha over 2, so it's equal to 0.05. I need my t experimental, or my t comparison, and then I also need to figure out what is my t of 0.05, and then my new. So let's go ahead and calculate our new right now. So I'm going to go into R. I'm going to use my new comp. So new comp, and then we're going to say S2, S3, and 2 and 3. We're going to calculate that there. Good. Hopefully there's not an issue with that. Those variables being defined as such. That is concerning. Hopefully, I think it should be fine. So I'm going to say that my new is 7. So I can go ahead and look at that right now. So 0.05, 7, 1.895. let's go back here just to check and make sure. Alpha, new, so 1.895, so that's good. And then where's my T experimental? So my T experimental, where am I going to find that? Here we go. So t-test comp, I'm going to use x2, x3, s2, oops, s2, s3, n2, n3. 2.25. So this is going to be reject. Excellent. Does, and let's, all right, so now let's go ahead, let's erase this. So that was a reject. We'll keep some things here. Does product one come from a population with a mean of 46.8? Mu is not that. So we're at confidence of 99, so our alpha is equal to 0.01, but it's an alpha over 2, so we need to do 0.005. So T of 0.005. Our new population, product 1, so that means it's a new of 26. We can find that right now. So 0.005, and then 26. So that'll be right here. So 2.779. I'm also going to steal from our lecture 5 all the way at the top this T experimental value. So I'm going to copy that in. I'm going to build that function in. So now my T experimental is going to be, so we're seeing our X bar, which is going to be X1. Our mu naught is going to be 46.8. Our S1 and 1. 10.3. That is for sure reject. Excellent. Would a measurement of 47.4 nanometers be an outlier? What about 46.8? Now, there are a number of ways you can look at this. So if, let's say, this is our population mean, we'd actually this is a pretty good question. So an outlier means that we are basically plus or minus 3 sigma away. So if I'm saying, let's say I assume, for example, that for product 1, this is our mean, and the standard deviation is such. So I can say if we are 47 plus or minus 0.3, if we're larger than that, then we can treat it as an outlier. So by this definition, this would not be an outlier. Actually, excuse me here. This would be an outlier here. This would not. But you're making several assumptions in here. One is that essentially they are all normal. That basically this is the sample is Gaussian, and we're applying effectively our rules that we've developed previously. You can be a little bit more comprehensive per se, and use that mu is approximately going to be our x bar plus or minus whatever the z c over 2 is times s of x over square root of n. And you can basically put like a 3, basically a number in front of this. But again, this is kind of just there's lots of ways you can approach that problem. Does product 3 come from a population mean with a greater than 46 at 90%? So now let's do 46. That's our null. Here we're going to say greater than 46. Let's get all the rest of this out of the way. We're working at a 90% confidence, so our alpha is equal to 0.1. So 0.1. For 3, product 3, that new is going to be 7. We can look that up right now. T.1 and 7. So 1.415. 1.415. And then our T experimental, we can just calculate that. Let's go here. I'm going to copy this whole thing, except we're looking at 46, product 3. And again, it's only a single-sided test. So let's control enter. Minus 0.565. So we are definitely in the do not reject regime here. Got it? And finally, does population 2 can mean less than 50? 50. We'll erase this, make it less than. What's our confidence interval? Our alpha is equal to 0.05. Good. It's a single-sided test, so we know that we're going to do 0.05. And then we're looking at product 2, so that's basically infinity. We could look over here. 0.05. And we can look at right at the bottom. 1.645 minus, because we're doing left-tailed test. And product 2, let's pull it up for our T experimental. And then we can have our X2, X2, 50, S2, N2, minus 7.54. That is for sure reject. And we can look at that right here. For that left tail test, we are going to reject H0. Excellent. That is problem 3. And next time we're going to do the same hypothesis testing protocol, but now p-values. See you then. Thanks. Bye.